the determinant of a matrix. You have learned linear algebra courses, and you must be very familiar with the algebraic complement method. In that method, you can change the determinant of a matrix of n by n matrix to n determinant of n minus 1 times n minus 1 matrices. And then you can convert it also to n minus 2 matrices, and so on, until you have 1 by 1 matrix, so that you can get determinant easily. So the mathematicians will say that there is an analytical solution. No matter what n is, there is a solution to a n by n matrix. But this conclusion neglected the complexity problems, and the computation amount required is this. So if n is 20, then if you calculate this, you will find that the value like this. If you are using a 10 billion blocks per second mainframe computers, it may take you 3,000 years to find the result. So it is not possible to use it. But if you are using a algorithm, I think you have learned something like a Gaussian elimination algorithm, something like that, and you can greatly simplify the result. And also in Matlab, you can use Matlab provided the command to solve it. You do not have to know what is inside the algorithm. You just use the result. Use the command and get the result. That's all. So if you are using Matlab, what you need to do is to first construct the matrix, and then use the simple command DET for determinant, and then you can get the result. And for this particular case, pure numerical method may fail because it is a matrix which is close to a singular matrix. So if you are doing it with a numerical method, you may get some errors. But if you are using a symbolic way to solve the matter, you will get something like this. It is exact result. So what you need to do is first to convert a numerical matrix into symbolic matrix. I will give details to this later on. And then use the command DET, use the same command, and you can get the exact result. And there are other examples. For instance, if you are trying to solve a differential equation problem, you can use numerical algorithm, because this one is a nonlinear equation. It does not have any analytical solution. So what you have to do is to get a numerical algorithm. If you learn the numerical analysis courses, you know that there are quite a lot of algorithms to use. However, for this kind of problem, the standard numerical solutions will give errors. So for this kind of equations, we have to use special algorithms. And this kind of solution is called the steep equation. I will talk about this later when I give lectures on differential equations. And in standard numerical courses, we do not have algorithms, something like this, for the delay differential equations. And also for fractional differential equations, there are no existing algorithms in normal numerical algorithm courses. So what you need to do is to read other books or papers to find the algorithm and code it by yourself if you are not using Matlab. But if you are using Matlab, you can use simple ways of solving this kind of problems. In Matlab, there are certain algorithms which implement the steep equation solver and also delay differential equation solver. And also we write some code for fractional order differential equations. It could be very easy to solve them. And there are also many other branches. For instance, in optimization problems, we usually consider linear programming problem. So this is a general, this is an example in linear programming courses. In this course, I will teach you what this means. Give a physical explanation to this one later on, and then tell you how to solve this kind of standard problem using Matlab. So what you need to do is to represent the objective function and the constant using simple way, standard way. So if you learn this course, you are able to solve this kind of problems immediately. So there are quite a lot of examples, and also in your college math, courses, some of my students will forget how to solve the problems after the final exam. So in this case, what you need to do is to remind you or teach you the mathematics course in a different way, in a problem-solving point of way, just to how to address the problem in Matlab and then how to interpret the result. So this is the main idea of this course. Now let me talk something about analytical solutions and numerical solutions to mathematical problems. In your calculus course, you have learned quite a lot of methods to solve problems. For instance, if you are trying to find derivative of a function, what you need to do is to follow the laws, Rocky's laws or other laws. Sorry, I got mixed up. The limit problem. You have to use different laws and to memorize different algorithms or different methods. And this kind of method can be carried out in a systematic way. So you can use step-by-step manual derivation to the problem. And this kind of problems are analytical solutions. There is not any approximation in the whole solving process. However, there are quite a lot of cases where analytical solutions to problems may not exist. For instance, you can recall your calculus course that there is no analytical solution to an integral like this. So what the mathematicians do, they introduce a notation, say that this is the analytical solution to this integral. And this conclusion is not enough for an engineer. For instance, the engineer may ask, when a equals 1.5, what is the value of the integral? Obviously, mathematician will get ER at 2.5. That is not meaningful for engineers. So the engineers must do it in an approximate way because there is no analytical solution, so we can use to divide the integration interval into several bins and then carry out to find the area of each bin and add them up. Then we can get an approximate solution to this problem. So this is the idea of numerical solutions. So there are two ways to solve mathematical problems. One is analytical and the other one is numerical. And in most engineering cases, analytical solutions are not exist. So we have to carry on numerical solutions to the problems. And in this course, we will try to find if